Hello friends, I am Chandan. Today's topic is cyclic process. So in previous lecture we understand the ideal gas equation and the relation between R and R bar. R equal to R bar by M. M is the molecular weight. Now in this lecture we'll understand what is the cyclic process. Now, cyclic process means a combination of number of process with initial and final points same. Suppose this is the PV diagram. This is the previous diagram, and here this is the initial point, initial state, and 1 to 2 this is one process, 1 to 2 this is one process, 2 to 3 there is another process, 3 to 4 there is another process, and 4 to 1 there is another process. And the initial point is 1, and the final point is also 1. If the initial point and final point are same, then you consider that it is a cyclic process. So if the initial point and final point are same, then you can consider this is a cyclic process. This that means it is a clockwise process. Here it may be clockwise or anti-clockwise. It may be clockwise and anti-clockwise, but in this process it is a clockwise process. And if it is a clockwise cycle, then it is a power producing cycle. Okay, in Otto cycle, diesel cycle, dual cycle, it is all power producing cycle if the cycle will be clockwise. And if the cycle is anti-clockwise, that means in that direction, anti-clockwise, then it is a power absorbing or consuming cycle, like VCRS. VCRS, that means VCRS, or you can say that there is a heat engine. So these all are anti-clockwise cycle. Now uh, some data you should remember. What is ideal gas equation? That is PV equal to MRT, and we know the process, first process, that is constant volume process. If it is a constant volume, that means V equal to constant, and if V equal to constant from ideal gas equation, you can say that P proportional to T, because in this equation here M is constant and R is constant and V is constant, so you can say that P proportional to T. So from here you can get this relation P1 by P2, that is equal to T1 by T2. Okay, now if it is a constant pressure process, then you can say that P equal to constant, so we get the relation, that is V proportional to T. From here you can say that V1 by V2, that is equal to T1 by T2. Very important here, this is the important. Now if there is an isothermal process, if it is a isothermal process, then isothermal process means temperature that is equal to constant. So temperature that is equal to constant, so you can say that PV that is equal to constant, so you get the relation, that is P1 V1 that is equal to P2 V2. Very important. Now if it is a adiabatic process means PV to the power gamma that is equal to constant. PV to the power gamma that is equal to constant. From here you can get this relation P1 V1 to the power gamma that is equal to P2 V2 to the power gamma. Very important. Okay, now there is a relation, that is P2 by P1 that is equal to T2 by T1 to the power gamma upon gamma minus 1. Remember, gamma is 1.4 for air. Gamma equal to 1.4 for air. Okay, so this relation is important. Okay, now from here you can see that T2 by T1. So here from this relation is also very very important. T2 by T1, that is basically V1 by V2 to the power gamma minus 1. Basically this formula will be written in this way. Suppose that is T2 by T1, that is equal to P2 by P1 to the power gamma minus 1 by gamma, that is equal to V1 by V2 to the power gamma minus 1. So this relation is very very important. Remember this data, that is very very important. You remember this formula, that is T2 by T1, that is equal to T2 by T1, that is equal to T2 by T1, that is equal to P2 by P1 to the power gamma minus 1, or you can say that equal to V1 by V2 to the power gamma minus 1. Very very important. From this relation you get this formula. You will get this formula. Okay. So in polytropic process means PV to the power gamma, that is equal to constant. PV to the power gamma, that is equal to constants. From here you can say that P1 V1 to the power gamma n, PV to the power n, that is equal to constant. So from here you can say that P1 V1 to the power n, that is equal to P2 V2 to the power n. So from here you can get this formula, that is same as adiabatic process. So here P2 by P1, that is equal to T2 by T1 to the power n upon n minus 1. N is the polytropic index, and you can get this formula T2 by T1, that is equal to V2 by V1 to the power n minus 1, same as this formula. Okay, so for polytropic process the formula will be like this: T1 by T2, that is equal to T2 by T1, T2 by T1, that is equal to P2 by P1 to the power gamma minus 1 by gamma, that is equal to V1 by V2 to the power gamma minus 1. So this formula, that is very very important. Sorry for that. So here there is not gamma, this is not gamma, there is a n minus 1. Okay, gamma will be n minus 1 by n minus 1. Okay, so this formula is very very important. Remember this formula, this is very very important. Okay, so okay, now there is a question. Read the question carefully. Here in a constant temperature process, 70 moles of an ideal gas at temperature 354 Kelvin attains a final volume V2. Acha. Next, work input during this process is 2066 kilojoule. Initial volume V1 of the gas approximately satisfies the following relation: E is the base of the natural logarithm. So basically you have to find out what is the relation between V1 and V2. What is the relation between V1 and V2? Now what is given in this question? Given there is constant temperature process. Constant temperature means it is an isothermal process. Okay, so what is given? This is an isothermal process. So when there is any question given in this first you should write the data. First you should write given. Okay, given that it is an isothermal process. Now what is given in this question? In an constant temperature process, 70 moles of an ideal gas, 70 moles of an ideal gas. 70 moles means there is a n value is given, that is 70 moles, 70 mole. So 70 into 10 to the power minus 3 kilomole, you can say that 70 into 10 to the power minus 3 kilomole. Okay, next what is given in this question? Of an ideal gas at temperature 3 354 Kelvin. So temperature of an isothermal process will be 354. So T is equal to 354 Kelvin. Now, in that question, what is given? Attain a final volume. Attain a final volume V2. Acha. Work input during this process is 206 kilojoule. So work input to the system is always negative. Okay? Remember this data. Work input to the system is always negative. This is the sign convention of work. So that is why here isothermal work input is there, so that is why this is a minus sign. Okay, that is 206 kilojoule. Now initial volume, that is V1, and final volume V2. You have to find out the relation between V1 and V2. You have to find out this relation V1 and V2. Now we know that for ideal gas for isothermal work, we can say that we know that formula n r bar t ln v2 by v1. So isothermal work is given, that is equal to minus 206 kilojoule, and what is the value of n? That is 70 into 10 to the minus 3. Here this is 70 into 10 to the minus 3 kilomole. Okay, put the value here, 70 into 10 to the minus 3. And what is the value of r bar? That is 8.31 into 354 is the temperature, isothermal process temperature, and ln v2 by v1. So from here you can get this relation ln v2 by v1, that is equal to minus 1, or you can say that ln v1 by v2, the negative sign it changes to positive sign if you write in this way, ln v1 by v2, or you can say that it is equal to ln e. So from here you can get this relation v1 by v2, that is equal to e. So from here you can get the relation v1, that is equal to e into v2. So this is the relation between v1 and v2. So this is a simple question, just practice this question. Okay, there is another question is given. I will not discuss the question answer. So the PDF link is given on the description. You can download it and practice the question. Very important. So this question is also very important. You can try this question, and answer is also given here. There is answer is also given on this question. Okay, now here there is another question, very important. You can get and there is solution is also given. And now there is some, you can remember some point here. Positive area represent work done by the system in the process. Positive area represent work done by the system. So remember this data. If there is a positive area, then work done by the system, and negative area present work done on the system in the process. Now third point is that net work done by the cycle is equal to the area enclosed by the cycle on PV diagram. When you solve this above question, you can understand this point. And if all the clockwise cycle you know that clockwise cycle are power producing cycle, and anti-clockwise cycle are power consuming cycle or absorbing cycle. Okay, so these are the data. You can remember this data. Okay, now there is another question. Solve this question, and the answer is also given. Okay, there is another question also there related to work energy introduction, and there is the answer is also given here. There is the answer. Another question. Always solve the question, otherwise your doubt is not clear. Okay, and this is the answer here. This is the answer. And there is another question, and here there is the answer. Okay, so try to practice this question. This is question, and this is the answer. So this question are very important for gate or ESC point of view. This is all about the previous year question. This all question are previous year question. Okay, you can practice this question. This is the answer here. Here this is another question, and here there is answer. There is an answer here. This is the answer. Okay, this is another question. This is gate 2020 question, uh, and this is the answer here. So just practicing the question. Practice is the ultimate key for success. Just practice it. If you practice more, then you will get succeed. Okay, thank you.